Alrighty guys, this is a video for IXL Identify Similar Figures. And in this exercise, we're given pairs of polygons. And previously, prior to this module, anytime we had a pair of polygons, like in our module on scale drawings or on dilations, we knew that they were scale drawings or dilations, or now we have a term for these sets of properties. We knew that they were similar. Now we're given pairs of polygons and they might be similar or they might not be similar. We're going to use the properties of similarity to make that decision, to be able to say yes or no. Okay, so what are the properties? Well, let's pull up a notepad here and let's write them down. The first property is that the pairs of corresponding angles are congruent or equal. Okay, and then the second property is that the pairs of corresponding sides, or the ratios between the sides, are proportional. Okay, and what does that mean for number two? What does that really mean? That means that if we decided to find the scale factor between pairs of sides, that we would get the same scale factor for all four pairs of sides in this figure. Okay, so in order to be able to say yes that they're similar, we have to be able to say yes to everything. All of the angles have to be equal and all of the pairs of sides have to be in the same proportion. If any part of this fails, then we're immediately going to click no. Okay, I like to start with the angles because I think they're a little bit easier, and then we'll move on to the sides. So let's take a look at our figure right here. I'm going to be using the IXL tools to help me out a little bit. All of these angles here are all 90-degree angles. They're all right angles, and we know that because of those little red squares. And look at that. They're the same between both of the figures. So as far as item number one here, we can say yes, the pairs of corresponding angles are all congruent. So now let's move on to the sides. Okay, so we want to find pairs of corresponding sides, and something that we talked about in class is to make it a little easier on ourselves. One strategy is to take the longest side, so the largest number that you see, from one of the polygons. So on this one we have a 25 and 36. 36 is bigger. And then do the same thing on the other. And that is definitely going to be a pair of corresponding sides. And then we make a ratio out of them. I like to make my ratio like this. I like to write it in reverse. I like to do the number on the right over the number on the left, just because that's how we did it when we had our scaled polygons module, or scaled polygons lesson, I should say. So we have 36 over 36. Okay, that's one of our proportions, and then we want to pick another pair of sides. So for this one, there's really only one other option, but what I would typically do next is go for the smallest pair of sides, because you know they're going to be matching as well. I'm going to write my proportion. I'm going to do 23 over 25. And we want to ask ourselves, are these the same proportion? Now, clearly they're different numbers, but they could be equivalent, okay? So how can we tell if they're equivalent? We're going to pop these fractions into our Desmos calculator here. You guys should have the link for this. It's in your checklist. The first fraction, what did we say that was? It was 36 over 36, okay? And that's just equal to 1. And then our other fraction is 23 over 25. I already know that that's not equal to 1, but we could just check it anyway. So 23 over 25 is definitely not equal to 1. And when you're comparing your scale factors, when you're comparing your ratios, you can compare the decimal version, or you can click on this little circle tool right here and compare the fraction versions. Either one will work. Just make sure you're keeping it consistent. Okay, so overall, we are seeing that 36 over 36 is equal to 1, and 23 over 25 is not equal to 1. So these two are not equivalent fractions. So therefore, these are not similar shapes. We're going to click no, and we are going to keep on moving. Okay. How about this one? Are these shapes similar? Let's pull up our little checklist here. Item number one, we have to make sure that our corresponding angles are congruent. We're going to do that first. And I'm already seeing that they're not. So immediately I'm thinking the answer to this is going to be no. But let me show you guys what I'm seeing right here. Okay. So I'm looking at angle D, and it has this single tick mark here. Do you guys see that? That little singular curved red line right there. And then I'm looking over at the other polygon, and there's no angle here that looks like angle D, right? Angle R has triple tick marks. Angle U has 4 or quadruple tick marks. Angle T has 3. Angle S has 4. Nothing has the same as angle D. So angle D does not have a matching angle in this polygon. Therefore, the pairs of corresponding angles are not congruent. Therefore, this has already failed. Remember, everything has to go perfectly in order for us to be able to say yes. So this is going to be another no. And I don't even need to check the sides. I don't even need to write out my proportions, although it looks like that wasn't going to work either. I'm going to hit submit. Okay, moving on to this one. Are these shapes similar? Okay, so remember, we're going to start off by checking our angles. Are the pairs of corresponding angles congruent? So looking over on the left, I have G, which has double tick marks, and O has double tick marks, so they match. H has double, and P has double, they match. I has single, Q has single, they match. J has single, and R has single, so they match, okay? So item number 1, does it have pairs of corresponding angles that are congruent? Yeah, it does. This one has been satisfied. We can't say yes yet, though. We have to make sure that all of the sides are proportional. Okay, so I'm going to erase all of that work, and we're going to move on to the sides. Okay, so while I'm erasing, you guys can start to look for the largest number on both sides. The largest number from each polygon. I'm going to start over here on the left. Largest number is 20. And over here, the largest number is 30. So my first fraction is going to be 30 over 20. Okay, then I'm going to change my color to blue. And I'm going to grab the smallest number. Smallest number here is 12. Whoops, I wanted to change that to blue. Smallest number on the left is 12. Smallest number on the right is 18. Let's go ahead and write that out. So that's going to be 18 over 12. All right. Now, these are clearly not the same fraction, but are they equivalent? Let's go check. Let's go test it. So 30 over 20. Let's clear this. So we have 30 over 20. And that's equal to 1.5, or it's equal to 3/2 when I click on this button. So that's equal to 3/2. I'm just going to write that right underneath, that that's really the same as 3/2. And then let's go test 18 over 12. Okay, so the numerator is 18 and the denominator is 12. Whoops. Denominator is 12. Ooh, look at that. 1/2 or 3/2 also. So it looks like this is pretty good. Let's check the sides as well, just so we're like completely sure. Let's check 24 and 16, just to, although this is looking like we are good. Let's check 24 and 16. Remember, all of the pairs of sides need to match. So 24 over 16, we're hoping to see 3/2. And we do, 3/2. Okay, so yeah, this one works. This one has congruent angles that match up, and all of the pairs of sides, they all have a proportion equal to 3/2. And the fourth side was just the same numbers. It was 24 over 16, so I didn't do that one again. Okay, we're going to say yes for this one. I'm going to do at least one more for this video for you guys, and then maybe we'll stop. Okay, all right, so I'm taking a look at these shapes right here. Remember, item number 1, we're going to check out those angles, and we want to make sure we have matching angles. With the previous problem, I went angle by angle and matched them up, right? I would say something like this, that Q and X match up, and that P and Y match up. But really, I'm like immediately noticing that they're all 90-degree angles. So I don't really feel like I need to go through these one by one. They're all the same angle. They're all 90. So clearly all of the angles are, all of the corresponding angles are congruent because they're all the same number. Okay, so we're going to say yes for that. And then how about this? Pairs of corresponding sides are proportional. And this is another thing where we're going to go ahead and set up those proportions, but let me just show you what I'm noticing. I'm noticing that the figure on the left is a perfect square. 33 by 33. The dimensions are the same for the height and the width. And I'm noticing that sorry, I almost said rectangle. The figure on the right is not a perfect square. It's a rectangle. It's 33 by 39. They're not the same. So these are completely different shapes and they're going to not be similar. But let's show why that is using our proportions, just in case you're not seeing it as quickly. So I'm going to pick my largest number on the left, which is 33. They're both 33. And my largest number on the right, which is 39. We'll go ahead and we'll write that ratio. So that's going to be 39 over 33. And then we're going to change our color to blue. And we'll do the same thing with the smallest number. So 33 and 33. So 33 over 33. Let's go over and simplify these both and let's see what they're equal to. 39 over 33 is equal to 13 over 11 if we want to simplify that in terms of a fraction form. So this is 13 over 11. Okay, that's the ratio or the relationship between the pink sides right here. And then 33 over 33, whenever you have the numerator and the denominator the same number, that's always just equal to 1. Okay, and I can show that to you guys over here, but that's a good one to remember, I think. Whenever you have the same number, it doesn't matter what it is. It could be a million over a million. It's always just going to be equal to 1. So that one, if you remembered that, you didn't even need to check. I can see that the proportions are different. And so this is going to be a no for this one. All right. And then there really isn't anything else that's going to be different. You guys are going to follow this same process for all of your problems. Remember, you have to check both things. You have to check your angles and you have to check your sides. As soon as you have some violation, so if you can see that the angles are not the same, you can immediately say no. In order to say yes, you have to go through the entire process, checking all of the angles and checking all pairs of sides. All right, go ahead, get in there and give this one a try.